advanced modeling. I think this is also an area that have some similarities. It could have some similarities with sensor integration, but in this case, we try to have another touch because I think there would be quite a good opportunities here as well. We know that in micromachining, we have size effect, microstructure influence, tool wear and breakage, and bear formation, chip evacuation problem, thermal damage, or damaging the parts, particularly if they are very sensitive in medical or watch industry. There are so many challenges. In that case, I just show you the bear formation problem that is quite a headache for us, typically. We do our best when we change from one material or one batch of a material to another batch, this type of issues start to happen. And that is really a problem. So the major challenges we have is a short tool life, poor surface quality, high scrap rate, and then economic loss. And this is really where we want to address. We have a very good setup that we've been developing through a lot of InnoSwiss projects in the process group, that we can do a very detailed analysis of the chip formation process. We do the characterization of the material. Then we have a model tuning, virtual testing, model integration, and then we bring all this information to application. So this is just one of the images or the more detailed analysis that I just want to share with you. So we have a setup that we can really see the chip formation. We have the microscopy access that we can have a detailed analysis of the workpiece. And the heart is really where we try to simulate the process. And these are microstructure adaptive. So even if you have a certain, let's say, titanium 6-4, if it's additive, if it's wrought, if it's cast, we can, to very good extent, get the mechanical properties, and then we can have a good simulation. What it brings us the possibility to have a virtual testing before we even do the model integration. But we also have a possibility for packaging this information for you so you can have a digital twin. And that is really where the strength of these methodologies really shine, I would say. A simple machine learning model that can allow you to have optimization. And for that, I can also show you this just very quickly. You know, we can virtually simulate the tool, really the break angle, edge radius, and so on, and then see what is really the outcome. And then we make a simple model for you that is not, these are all done in the background, and that's really easy to manipulate. And then you get a better idea really how you optimize your process. So this is just another idea. Yeah.